In this video, we're going to solve applications involving conditional probability and the multiplication rule from 3.2. So the accompanying table shows the numbers of male students and female students in a particular country who received bachelor's degrees in business in the recent year. We're going to use that table to complete parts A and B below. So find the probability that a randomly selected student is male, given that the student received a business degree. So male given business degree here is going to be 181,925, that intersection between male and business degree. Out of all the people that received business degrees, since that was the given group that we're looking for the subset of. So this is 351,548, and we want to round that to a decimal with 3 decimal places. So 181,925 divided by 351,548, and this is going to be 0.517. Since the fourth digit is a 4, which is less than 5, we're going to round down to 0.517. Now let's find the probability that a randomly selected student received a business degree given that the student is female. So we've got all females as our denominator here of 1,071,392. We want the intersection of females and business degrees. So that's 169,623. So 169,623 divided by 1,071,392. We're going to round this to 3 decimal points as well. It's going to be 0.158. Because that fourth decimal point is a 3, we're going to round down. All right. In a sample of 1,000 US adults, 211 think that most celebrities are good role models. 2 US adults are selected from this sample without replacement. That replacement is important here. That's what makes this dependent. Complete parts A through C. So find the probability that both adults think that most celebrities are good role models. So we have 211 to choose from out of the 1,000. And once we do that, then there's 210 left for the second choice out of 999, because we've chosen that person and not replaced them. So let's figure that out. 211 over 1,000 times 210 over 999. And we want to round to 3 decimal places, 0.044. Because that next decimal point is a 3, we're going to round down. Now we want to find the probability that neither thinks that most celebrities are good role models. So let's take the 1,000 minus the 220 or the 211 to see how many don't think that celebrities are good role models. There's 789 over 1,000 that don't think that celebrities are good role models. And then the second person is going to be 788 over 999. So we have 789 over 1,000 times 788 over 999. That's going to be 0.622. All right. And now let's find the probability that at least one of the two adults thinks that most celebrities are good role models. So at least one is going to be the opposite of neither. So we're going to take this 0.622 that we just found and subtract it from 1. So 1 minus 0.622 is going to be 0.378. The probability that a person in the United States has type B positive blood is 11%. 5 unrelated people in the United States are selected at random. Let's compare parts A through D. So let's find the probability that all 5 have type B blood. Because they're all unrelated, they're all independent of one another. So we would have 11% is 11 out of 100, and another 11 out of 100, and another 11 out of 100, and so on, which we could write as 11 out of 100 to the 5th power. So let's write that, 11 out of 100 raised to the 5th power. And that is round to 6 decimal places. So I have 0 point, and I have 4 zeros in front of this 1. 1, 2, 3, 4, 1, 6. Now let's find the probability that none of them have type B blood. So that's going to be 89 over 100 times 89 over 100, etc., which is going to be 89 over 100 to the 5th power. And that is going to be 0 point, and it says to only round this to 3 decimal places, 5, 5, 8. And the probability that at least one of them, so we're going to do 1 minus that answer that we just had. We're going to round to 3 decimal points, 0 0.44, and we're going to round that up to a 2 because that 5 is going to round that up to a 2. And which of these events is considered unusual? So which of them has a probability of less than 5%? Should be what we're going for. So the event in part A is unusual because the probability is less than or equal to 5%. I believe that is it. Yes. So we'll come back next time and we'll start talking about 3.3. See you for the next video.